Hello, and thanks for coming. So this is on-demand developer environment with Kubernetes, and I'm Enrico. If you were expecting Olivier, he's sick, so I will do it all myself. So what is a developer environment? It's a safe place where developer can deploy their code and test it and make sure that it behaves as similar as possible to production. To have one, you will need a sandbox, you will need some data, and you will need orchestration. And we will try to cover all those points today pretty quickly. In our context, it looks like this. You have an Helm deployment in Kubernetes, and we have very few pods, the smallest possible amount of pods. And as we will see, we run also all the data storages in Kubernetes. So I'm Enrico, hello. I work in the infrastructure team at JobTeaser. And JobTeaser is a platform that mission is to connect students with companies and make sure they find the best possible career path. We have more than 2.5 million students, 70,000 companies, and we work with more than 700 universities in Europe. We are a team of 300 people. The tech team is 90 people, and more than 150 people scattered across Europe for sales and university. And the infrastructure team, including myself, is 3 people. So we had to find a way to test our code easily. Olivier is sick, but I'll present him anyway. He worked for Xebia, and he was a big part of this project. And so what are the technologies we will cover or try to cover in these 30 minutes? AWS, because all our infrastructure is deployed there. We will see we used a lot of RDS, some Lambda, EC2, and other weird things like Heaven Bridge. Kubernetes and Helm, that I hope you are familiar with. All our code and projects are deployed in Kubernetes, and we pack them with Helm. And then Circle CI and Spinnaker for building and deployment. At JobTeaser, we call the developer environments also feature environment or Feature-envs. So if I do mistakes on the naming, please don't get fooled, it's the same stuff. And now we can start. So what is a deployment? It's the magic that will move the code from your laptop to the internet, and how can we do that? So about 2 years ago, that was kind of the environment we have at JobTeaser. We have some developers, about 20 or 30, that were building stuff on their laptops. They were pushing to Git. And then there was a CI that was pushing to staging, doing some tests there. And if it was OK, we were promoting to production. For a long period, this promotion was even manual. So how a developer could have tested things outside his laptop? For example, a database migration or some API, strange API changes with external providers. His only way was to use staging. But then what happened if you have 2 developers or 5 developers or 10 developers testing database migration together in staging? Well, it broke. And that happened a lot of times. And that was a problem because not having staging was blocking our CI because it was the only place where the CI could have tested before promoting something to production. And that means if somebody broke staging because they were testing their code, that what you expect developer to do, production was not accessible, almost not accessible anymore by the normal flow of things. And so that was our first key problem to solve. Our other problem was the data. We had a big monolith application with a very fat database. And that database contains, of course, user data. And so you had to create something to at least anonymize the data for staging. And then from staging, you need to have something that could have let developers download a small set of information on their laptop, because they couldn't download, I don't know, 500-600 gigabytes every week of data. It doesn't scale. And so to solve these two things, we provided them with developer environments. So we have a subset that they can fetch all the times. And they have an environment in Kubernetes that we will see it behaves the same as staging or production, that they can use seamlessly, like they can do with their laptop or the other environments. This is our current pipeline, and we will try to cover it from end to end. To take care of the deployments, we decided to split the CI and the CD. So we have a CI that builds all our artifacts that are only 3. We will maybe see them later. It's an Helm chart, a Docker container, and a configuration file. There is the only thing you need to deploy. And then for the data, we had to build our own pipeline to make sure that all the data was flowly properly from production to staging and then to the environments. So we will check the data pipeline first. Why you need the data pipeline? As I said, our production database has customer information that are, in our case, student profiles. So I would say pretty variable information. And for sure, you don't want anybody to access that if they don't need it. For sure, developers don't need those kind of data. And so we built our pipeline that had 2 outputs: a full anonymized database that in the form of an RDS, and anonymized subset that was actually just a tar.gz file. The anonymized database was accessible from staging, was the actual database of staging, and we will see how it was also accessible from developer environments. The subset was always accessible for developer environments and for direct download. So how does it work? We start from the snapshot that RDS did do for us every night. And every weekend, we have Amazon Event Bridge that with a cron trigger the restoration of this snapshot in a new database. When this is done, it triggers a Lambda function that will start the anonymization process. The anonymization process is an EC2 instance that runs for about 12 hours, and it gets through all the data that we have in the database, and it will chop all the personal information. We use Faker library, so we don't really reinvent the wheel. But we have to get through all our tables because, well, sometimes they're weird. When this thing is done, we trigger a snapshot, and that snapshot is the snapshot of the RDS instance, so it's available in AWS for use. And then we continue the process, creating the subset. So we dump the RDS into the instance that runs on MySQL, and we cut all the data we don't need. We keep about 1% of our data. And when this process is completed, we stop MySQL, we create a tar.gz of the MySQL folders, and we upload this to Amazon S3. So this entire process takes about, I would say, 15 hours, where 12 are the anonymization, and maybe 3 are just data transfer. It can be improved, of course. But it was the easiest way we had to just work with the pieces that were available, because there was an anonymization that developers were running a lot of years ago on their laptops, and so we just kind of tried to reuse what was already there. So let's see how we orchestrate all those pieces together. This is the right thing. So as I said, you push to Git, and there is Circle CI that will just run your builds. We build every commit except duplicates. So for example, if you push 3 commits one after the other, of course we build only the last one. But then everything is built and everything is pushed to our Docker registry and to our Helm chart registry. Based on rules, for example, you are in the master branch or you're using, you flag that you want a developer environment, we trigger Spinnaker. Spinnaker is our deployment tool, and to trigger it, because Spinnaker runs inside our AWS infrastructure and it does not provide authentication on their APIs, we had to build our small API authentication layer, and we did that with API Gateway and a Lambda. That's really just, we share token, and then we have a Lambda function that checks if the payload is okay. And then Spinnaker will take the decision and deploy your developer environments or your staging environment, or if you really have the rights, you will deploy to production. So it's actually deploying across different AWS accounts and different Kubernetes clusters. Thanks to this kind of configuration, we managed to have a pretty simple Circle CI configuration file, because you just need to run a test and build step that if your Docker container is well done, it can be pretty shim from the Circle CI point of view. We push the chart if you are in our developer or master branch, and then we trigger Spinnaker. To trigger Spinnaker, we use the publicly available ORB. We pass a bunch of parameters, and we build an horrible JSON payload. This thing, it really just does a curl request for us. It's pretty simple. And so this is what our environment looks like. We have our Helm chart. It deploys the monolith application that is composed by 2 or 3 pods. Mainly, you have a web pod that runs the Rails, and a worker pod with Sidekick. And then, instead of connecting to a lot of external and expensive and very slow services, we run our MySQL pod, Redis pod, and Elasticsearch pod. And those things are backed by an AWS EBS that is just fetched from S3. So that's pretty fast. But as I said, the chart is always the same. So the only thing that actually changed is the value file. So for example, this is the value file for your developer environment. You want 1 pod, 1 worker, 1 web, and the MySQL database inside Kubernetes. So if you want to have way more pods, well, that should be simple, because we know that we can just pass a different value in our config file. And if you actually want a bigger database, for example, you want the same size that you have in production, well, you can go manually in AWS, spin your RDS instance, and then change the configuration manually. But that was really not the experience we wanted for our developers. We wanted something like this. You put your worker account, your web account, you disable the MySQL running in Kubernetes, and then you need to have something to trigger the MySQL on RDS. That's specifying the class that you want, the storage that you want, and whatever other configuration is available to use in Amazon. So how did we achieve that? Well, with CRD. So CRD are custom resource definition in Kubernetes. And they will let you create your custom resource in Kubernetes based on actually just your code. So you can build them from scratch. That's almost what we did. And that actually enabled us to attach an external resource to Kubernetes and make sure that it behaves the same as everything else in your deployment. So in our case, we had our RDS. Why we have this arrow here? This is the thing. Okay, so we have our RDS manifest or resource in Kubernetes, so just a YAML description of what we want. And we built the controller that was checking this resource, and then it was triggering the APIs of AWS and do what we asked. This enabled us to just have a manifest, as I showed, that we're just passing configuration, and then the controller just was creating, updating, and do whatever you needed in AWS. And that means that you didn't need to do any manual operation in AWS. So actually, most of our developers don't even have writing access to AWS because they don't need it for this. And most importantly, when the developer environment was deleted, because it was not in use anymore, the controller is going to delete your resources, so you don't have scattered databases that are unused all in your infrastructure. So, to recap, to provide our developers with environments that behave as production, we just needed to cover two main points. The data pipeline, moving data from production to the developer environment. And then the deployment, that thanks to Helm and Kubernetes was pretty simple to scale down, and thanks to CRD was pretty easy to adapt to the needs of developers. So we know that this is good enough for now, but because we are growing a lot as a company, and we are building all our new product as microservices, now we are posed with the question of how do you make sure that your developer environment can behave if you have 20, 30 different microservices together, because you don't want that configuration of the developer environment gets too crazy. You want your developer environment to be pretty fast. I guess that right now you can spawn it in maybe 1 or 2 minutes. It takes more time actually to get the TLS certificate than to have them running. And we're having Kafka in production, and we are really threatened by how do you replicate an entire Kafka cluster in 1 or 2 pods? And then we're using other AWS services. As I showed, we're using Elasticsearch, we're using Redis, and right now the CRD that we have is custom made, and that doesn't scale, of course. So we are checking other provider for CRD, for example, AWS Service Broker or Crossplane. So that's it. And thanks for the attention. I hope you have questions because we have some time left. And please scan the code, leave feedback, good or bad. Thanks. We have a microphone for the questions.
Okay, yeah. You just said that you needed to cut through the data in your database before deploying to a dev's environment. But then you said the whole process takes a lot of time to anonymize everything. So why not just cutting it before anonymizing, when you're making the dump and then just cutting through and then just take what you need and anonymize just that part? What made it impossible, or what made it not interesting to do in the first place?
Mostly it's because we want to have a full set database available for staging. So our staging, the database that's using staging is exactly the same size as production with the same amount of data. We need this because our application is a monolith with, I would say, 8 years old of code. So some part of it are done by people that are hopefully gone. And so there are parts of the database or parts of the code that we really don't know about. And so it's easier to just remove the user information so you are sure that there is no risk on using the database, and then chop what you know you don't need. And then the process runs in batch. So every weekend there are some stuff in AWS that runs this thing, but you always have the latest subset available. So if for whatever reason it fails, or if you want to run something, you always fetch the data from the week before. Actually, up until 3 months ago, this process was triggered manually. So most of the times you use data that was 1 or 2 months old. You don't really care.
Okay. Good. Thank you.
My question concerns CI/CD process, and why there is two different tools for CI part and CD part?
So we have two main reasons. First, ownership. In JobTeaser, last year we took the decision that squads are autonomous. So they can decide what language they want to use, and they can decide how they want to deploy their things. So giving that freedom was pretty good for the product in general, but that means that now we have some code in Rails, some code in Go, some in Elixir, some in Python, some in I have no idea what. And we were using Jenkins for building and deploying to everything, but that was getting too bloated. So we had the need of moving to, I would say, fresher platform. And that's why we adopted Circle CI. But then the ability to deploy to Kubernetes of Circle CI is terrible. And that's why we decided to use Spinnaker. That is a very challenging product, but it gives you a lot of functionalities and a lot of granularity in the way you can do the deployments. And that's why we decided to split. This helps also from an ownership point of view, because as soon as developers can provide us with the artifacts that are here, the Helm chart, the Docker container, and the configuration file, I don't care how they build them. And I am sure that I can deploy them. And so that actually enables us to, I would say, iterate a lot on how they want to build their things.
Thank you.
Hi. How do you deal with data changes regarding the structure of the database? Let's say you have a new feature, for example, that is currently in development, and you load an anonymized subset. And for instance, your code may differ because you have, I don't say, alteration on tables and so on. How do you deal with that?
It breaks.
Thank you.
No, well, I have no idea. I mean, we keep our database migration in Rails. So it's actually Rails that runs all the changes in the database. And we are most of the times agnostic of that process, because for what I know about the DB loader pipeline, because this is I will shame Olivier, he did that, so I don't know. But we dump the structure. So whatever change in the SQL schema is just dumped in the new database. So you mostly don't care about that. And then we just scan it to search for user data. I'm pretty sure we use a library for that, so maybe there is some magic there. But you know, if you do a select all and you just get through every line and you cut the stuff, it kind of works. And when we run the subset, sometimes we broke stuff. So recently there were some schema changes, and it was necessary to add new things in the subset that were, I would say, cut differently. And so we had to actually manually change the DB loader code. So it breaks. We have 5 minutes, so a lot of more questions if you want.
Yes, hi. Just have one question. The title of your presentation is on-demand development. So, for the moment, we only saw the services, the pods, everything. But how do you spin up your namespaces? How do you spin up your load balancers, maybe? Or
that's Kubernetes. So the on-demand part is because you can just trigger Spinnaker to deploy your environment, and then when your deployment is done, you're returned with the URL to access it. Right now, we deploy everything in the same namespace. It's not the best thing, and then all the resources are just managed by the Helm chart. So in our case is an ingress, bunch of services, some pods, and there is no big external configuration to do. And even if one day we will move to different namespaces or maybe even different clusters, Spinnaker can handle that. So it's just a matter of finishing your pipeline and retrieve the information from Spinnaker to give them to the developer when everything is done, so that they have the pointers to access their thing. On top of this, the naming is conventional. So the environments are called with your application name, a tag that if they are short or long, meaning if we can automatically delete them after a week. And then there is the PR number. So you kind of can always figure it out.
okay.
We have one here.
Hello. Please, can you tell us more about CRD, custom resource? What's that? It's a configuration file. Can you tell us more, please?
So your question is, how are we configuring the CI and the CD? Oh, the CRD.
CRD, okay.
Okay. So do I have it? No. Yeah. Well, let's keep this one. So the CRD we are using is a fork, I guess, from Crossplane. So we just get what was available, and we try to adopt a publicly available CRD, but it was lacking a very important feature that was restoring from a snapshot. And so we actually add that, that part to the CRD. And now it's already there. So if you just go and check Crossplane, they provide you CRD for a lot of Kubernetes, a lot of AWS resources, and they just work. Another good alternative is an AWS Service Broker, so you actually don't really need to build it yourself because there are a lot of CRD already available. Okay. Again, thanks everybody. Leave the feedback.